In this video, I'm going to be teaching you how to solve question 15 for the Unit 2 problem set. This is the one with the fence and the ball, and we have to figure stuff out. So we have a ball of mass 0.5 kilograms initially at rest. It's kicked toward a fence from a point 32 meters away. The velocity of the ball as it leaves the kicker's foot is 20 meters per second at an angle of 37 degrees above the horizontal. The top of the fence is 2.5 meters high. The ball hits nothing while in flight and air resistance is negligible. So the first thing I want to point out is that we don't actually need this information. So I'm just going to cross it out. So first we want to determine the time it takes for the ball to reach the plane of the fence. So basically what they want is how long does it take to go this 32 meters? Will the ball hit the fence? If so, how far below the top of the fence will it hit? If not, how far above the top of the fence will it pass? And then for part C, we've got to sketch the horizontal and vertical components of the velocity. So I think it's always a good idea to start out with your chart for both the X and Y directions. So in the X direction, we can easily calculate the initial velocity, which will remain at that velocity because there's no acceleration in the X direction. So Vix is equal to Vi cosine theta. In this problem, that would just be 20 times the cosine of 37 degrees. So we end up with 15.973 meters per second. And then in the Y direction, it's Vi sine theta. So 20 times the sine of 37 degrees, which is 12.036. In the X direction, the acceleration is 0. We know that the initial position is 0. The final position is 32, and we don't know the time. That's actually what we want to find for part A. In the Y direction, the acceleration is negative 9.8. The initial height is 0. And we actually don't know the final position. And the reason why is it could go something like this, or it could go something like this, or it could even hit the fence exactly. So it could go something like that. So, like I said, we don't know YF. To figure out T, we actually just need to use the X direction. We can use the second kinematic. So XF minus XI is 32, so that's the displacement. So we would just want to enter in a 32 for delta X. And then since AX is 0, we can just entirely get rid of that term in the second kinematic. And VIX is 15.973. So if we just divide both sides by 15.973, well, that should be a 3 there, we get 2.003 seconds. And you can just, if you put 2, I will still count that as the correct answer. So then part B asks us, does it go over the fence? Does it hit the fence? Where does it land by the time it's gone this far horizontally? So what we're looking for is YF, and it could be exactly 2.5 meters, it could be greater than 2.5 meters, it could be less than 2.5 meters. So again, we want to use the second kinematic, but this time for the Y direction, we just plug in our variables. So we got the time from part A of the problem, so that was useful. And we end up with YF being 4.44 meters. So it goes over the fence. The problem specifically asks us by how much. So when the ball reaches the fence in the X direction, it will be at a height of 4.44 meters, and that's greater than the fence height of 2.5 meters. So the ball goes 4.44 minus 2.5, which is 1.94 meters higher than the fence. So we've done parts A and B. Part C, we have to do velocity time graphs in both the X and Y directions. For part C, it's pretty easy. So that velocity we got from the x direction was it was around 16 meters per second. So on this graph, we've got from 0 to 2 seconds, it's at 16 meters per second. If you continued this line, you don't want to do that. I'm going to erase it. It specifically only asks you to graph it up to the plane of the fence. So you only want to graph it till 2 seconds. Next, we want to graph the vertical component of the velocity. I want to point out that we know it'll be a straight line because the acceleration is constant. I like to make a little chart. So first I know that at 0 seconds, the velocity is that 12.036. Then I can use the first kinematic equation to find out what the velocity is at each second after that. So I would want to plug in I would want to plug in 12.036 for VI, and then I know that the acceleration is negative 9.8, and I want to find it for its velocity at 1 second. So its velocity at 1 second is 2.236. I'll also find it for 2 seconds using similar information, using the first kinematic equation again. So at 2 seconds, the velocity would be negative 7.764 meters per second. So I can just graph all 3 of these points, and your graph should end up looking something like that. Now the slope of this should be around negative 10 because acceleration is equal to negative 9.8. So let's see if that's true. So it looks to me like, yes, this is a slope of around negative 10. And again, you need to stop your graph at 2 seconds because it specifically asks you to only graph it up to the plane of the fence.